Günaydın. I'm Suresh Chandrasekaran, Executive Vice President at Denodo. I'm here from Palo Alto, California. I'm going to talk to you today. By the way, thank you, Christina. You made my job easier from Google. She explained what is happening with data, big data, so well that you all understand the possibilities. And now I'm going to talk about how to put it to use in the real world with some examples of companies. So my talk is about what's next, the role of data in real-time digital transformation. So let's take a look. What is digital transformation? Well, it's not only digital. That's why we start with people, process, and technology. So all three play a key role. And our view of digital transformation is that it needs to address the business challenges, the corporate objectives, which is customer satisfaction, profitability, growth, and also take advantage of opportunities. And in doing all this, data plays a very key role. Now, there are three pillars of digital transformation that companies often talk about. And the first and most important one is the customer. How can you change the experience that the customer has with your company using digital transformation? In fact, the previous speaker, Christina, gave many examples, how the drive-through in McDonald's can be different, how a patient in a hospital can get better care. If you're using a digital banking application, how it understands your previous transactions and maybe makes it easier to make the next transaction. You see these examples all over you. The other part of digital transformation, the second big pillar, is how can information create competitive advantage? Now, this is not only in the front end, as in customers, etc., but it can also create digital advantage in how you innovate new products, how you reduce the cost of your supply chain. And I'm going to show you some examples of that. And the third and very, very powerful one, even though 41%, which is lower than the 66%, want to do this, this is the most powerful one. You completely change the business model in your industry. So you all know that there are many examples of that, or taxis, or how we rent vacation properties, how we pay for certain things are all being changed based on data. So digital transformation is all these things. And if you kind of dive a little bit deeper, you also see that this can be broken down. I really like the right side of this picture, the kind of the pyramid, because it's very easy when you attend these kind of conferences. You want to do two things. One, you want to be inspired about the possibilities of the future, but you also want to have a place to start working on this today. So that's why I like the idea that you have to first address the fundamentals. How do I reduce costs? How do I better meet the customer demand? And then from there, you can start to think about how we can better manage risk, the data security, the privacies, things like that. And then add on top of that the ability to innovate and do autonomous decision making. That is data-driven decision making, which allows you to accelerate the progression of the business. And then finally, the competitive differentiation or the new revenue streams or new services that we talk about. So taking the three pillars of digital transformation and working on it in this kind of pyramid fashion makes a lot of sense. So it depends on what kind of company you are. Maybe not every company here is a Netflix or a Uber or a Facebook. We may be a manufacturing company, a distribution company, a hospital. So you still have the chance to achieve that vision by taking this kind of a stepped approach. So therefore, I picked a company that's not very well known. It's a company called Festo. It's near Stuttgart in Germany, and they are one of the world's leading manufacturers of factory automation products, the pneumatics, the electromechanical systems that do the factory automation, etc. And they supply all of the major industries like manufacturing, automotive, food processing, etc., etc. So this company, Festo, and I picked a smaller company in purpose because I think people need to understand that big data, digital transformation, and the use of data is not just restricted to the biggest of the biggest companies, but it's for all of us. So Festo is already a leader in its industry, but decided that was not enough. They wanted to have this digital transformation journey that touches on all of the three pillars that I just talked about. So if you look a little carefully in this picture, there is the digital enterprise. It's finance, human resources, corporate functions, the digital workplace. How can I make that more digital? First, focusing on the employees of the company, the factory floor worker, the production specialist, the quality control person, etc. Then I need to think about how digitalization can impact my supply chain. The people who supply me parts, the materials, even the food service for the canteen. How can we distribute it better in the outside, etc. How can I then have digital products and services that enhance the experience of using my product and create new revenue streams? And then what will be the customer interaction, the digital customer experience? And then finally, you see on the top, can I change the business model from just selling components to ensuring better uptime in factory automation processes, or provide more value to my customers such as car manufacturers, Daimler-Benz or Volkswagen or whatever. So they were looking at this as a roadmap. And the interesting thing, if you look at this, is at the center of it is analytics and data. How can I leverage all of the data and all of the analytics in order to bring about this digital transformation? I'm going to come back to Festo and see how they did it in a few slides. But before that, the first thing we analyze is in this survey that was done by Altimeter Digital, the top areas of investment that companies are making for digital transformation, you will see data is key. So, of course, cloud is not just data, it's also applications, etc. But a lot of the big data initiatives that we talk about are actually starting to happen in the cloud, particularly with the unstructured data. Of course, you still have your on-premise, inside your data center data like CRM systems, supply chain, ERP, etc., etc. But cloud is very big. And if you look at 4 of the top 6, they're all very specifically around artificial intelligence, Internet of Things, which is sensor data coming from machines, equipment, your windmills, your traffic signals, everything that you see around you in the physical world sending data. That's Internet of Things. And big data, which was well explained again by Christina, and of course real-time analytics and reporting. So 5 out of the 6 top investments for digital transformation are very much around or surrounding data and analytics. And so you have all probably seen this said many times. This was from 2017, where The Economist basically said the world's most valuable resource is no longer oil, it's data. But this is not easy. And so most of my presentation is going to focus on how you do it, because you already know you want to do it. You know the top companies in the world are doing it. But what about the rest of us? How are we going to make this journey? The data is hidden. Even if you have information, if you're a bank here, and we're working with some of the top banks here and some telcos along with our partners, the data is in so many different systems, in so many different formats. Most people don't even know what's in these databases. It's hidden. So if I'm going to try to do analysis, first I have to find the data, and that's not easy. Second, the data is not where it used to be. It's moving. So the typical cloud journey is not a one-step, just let's move to the cloud. It takes several phases. First, you have all your data on-premise. Maybe you start then using some SaaS or software as a service applications like Salesforce or ServiceNow or NetSuite, or there are many, or Google, for example. And then you go into one of the cloud providers, AWS, Amazon Web Services, Microsoft Azure, Google Cloud, or if you're in Asia, Ali Cloud. But you may start with one, but very often you go to multi-cloud. You may have your clickstream data being analyzed in Google, and you might be having some kind of social media data being analyzed in a different cloud. So it starts getting complex. Over the period of time, you may even become cloud native, or you may continue to be in a hybrid scenario. So the data is hidden inside the enterprise. Now it's more complicated because it's moving in multiple places. And of course, as we all know, it's growing. And it's not just the growth in volume, it's also the complexity. So you see the variety of data sources, the different types. Every day, every month, you read an IT journal, you see more and more types. So this is flat files, this is big data, this is columnar database, this is mapping data, this is so many different types of data. And then the volumes, and then there are different types of processing that you can do. You can do statistical analysis, you can do big data analytics, predictive analytics, machine learning, and then the types of outputs that are sought, whether it's predictive or automated decision making, everything is increasing. So the number of data sources, the number of tools that you have, etc., are also increasing. So it's a pretty big challenge, I would say. But by the way, interestingly, spreadsheets that we used to use 20 years ago are still one of the biggest data sources, and that are completely uncontrolled. So you have now security issues, privacy concerns, is your data leaking to the competition, etc. So despite all these challenges, many companies are starting their journey into AI projects. But you'll see that many people are starting, but the deployed percentage here, which is in the blue, is very, very small. So people are acquiring data, spending the money, throwing it into the big data stores, buying the tools, but are they getting value? This picture would indicate that while everybody is eager to rush into this big data world, the analytics world, the challenges that they face, which we just saw in the past couple of slides, are so big that the amount of progress that they're making is not that great. At least for the normal companies here that we can think about, except for the very, very, very super big ones. And the reason for that is when you think about analytics of any kind, even simple reporting, etc., but particularly advanced analytics, these companies are spending 80% of their time finding and preparing the data, and only 10% of their time doing the analysis and then visualizing the data to actually create results. So now let's talk about one of the potential solutions. What you really want is to be able to get the data that you need, when you need it, and how you need it. Not all the data, only the data that will help you make decisions, change business models, improve customer experience, the things that we really want to do. That would make a huge difference. And the way that you can get there is with the concept of logical data architectures, data virtualization, which I'm going to talk about. Now, this sits on top of all the other technologies. So this is not instead of, but you've made your investment in big data, you've made your investment in different analytical tools, but how to find the data virtualization helps. This is a very dense slide, so I'm not going to read all the words, but for those who want to go into it later, they can. The main concept, forget the words, I should have built it up as a build-up slide, is that at the bottom level, you have the complexity of data. That's the world of IT. They are bringing in new data, they're bringing in new systems, they are migrating systems to the cloud. They have traditional data warehouses that are represented by the cubes, traditional databases, maybe mainframe systems, maybe SaaS applications, maybe unstructured data, etc. But the business does not think in bits and bytes. The top blue layer represents the business, marketing, product development, finance, risk in an insurance company, those kinds of functions. They want to understand the data in business terms. Who is a customer? Who is a supplier? What is my product? What is my pricing, etc. So what you want to do is to provide the first point here, the idea of abstraction. I create a buffer area or a way for all this complexity at the bottom to be masked by this data abstraction, so that the data can be viewed by the business more in business terms, entities, business entities that make sense to me as a business person, as a marketing person, as a salesperson. When you do this, you don't want to copy all the data. You want zero or at least minimal replication or relocation of the data. Why? If we are creating so much data, as the previous speaker mentioned, if I keep copying the data again and again and again, which Gartner, one of the big analyst firms, says that a company sometimes copies the same data 15 to 20 times. Imagine the amount of storage, imagine the amount of people needed to manage that, and the costs associated with it. Worse, it slows you down. So you want to do this abstraction layer with minimal replication and relocation, which then allows you to go get the data from the source systems in real time or near real time. Now, coming back up to the business layer, this abstraction layer needs to provide the business users the capability to find the data. Remember, that was our first objective. And self-service data catalogs or data marketplaces are very important, because now this organizes all of these views of data by business entity in a way that you can find it, and also understand who is using what, have recommendation engines on which data you should consider. Now, while all this is happening, I again go back to the bottom layer. IT is very concerned about security and governance. They want you to have self-service, but they also need to make sure only the right people are looking at the right data, the data is secured or masked, and the data usage is governed and trustworthy. And then finally, you need to be able to deliver this information in any format. I'll come back to the idea that digital transformation is not only analytics, but it's also applications. So applications may want to consume the data as data services or web services or REST or whatever technology terms you want to use. And analytics may want to consume it as, let's say, SQL or database or analytics. So there are different formats that people want, and you need to be able to deliver that. So keep these 6 concepts in mind, and that's what a logical architecture or data virtualization does for you. So now let's come back to our friends here at Festo. They recognize that their digital transformation journey was so centered on data and analytics that the architecture, I know this is a very technical slide, really started to put this abstraction layer at 2 levels. First, between all of the different types of data sources, structured, machine, social, semi-structured, non-structured, in a way that they could first be normalized to the point where the technology changes underneath did not impact them, and they would come into their intermediary storage areas, like analytical areas like big data on Hadoop, the data lake or the data cloud, IoT cloud, as well as the traditional data sources like the enterprise data warehouse, etc., etc. But then they also put this logical layer on top, which allows the users now, the analytics users, the big data or what we call data scientist users, as well as the customer services and other applications, to be able to consume this data in different ways. I'm not going to read all the words there, but you get the key ideas. So data virtualization becomes a key component of their analytics and big data architecture and allows them to handle this growing amount of data and have a single place where all of their different applications can come. Remember that these areas are not storing the data a second time or a third time. They are logical. Just like your playlist on your Apple iPhone is not storing all the songs 4 times, it's just a playlist. So think of it like that in a way. It's a logical architecture. It works with the physical architecture, the storage architecture is beneath. And then it operates. So this now allows changing of sources because you have this buffer. Let's say you want to move a data from one source to the cloud, or from flat files to a relational database, or from that to a SaaS application. You can do that without impacting the business. And now you've also enabled the business to take the data that they want and shape it into business-oriented data models. So how this actually works, maybe too technical for today's keynote, but the idea is you build a representation of the physical data sources in the logical layer, which we call, if I go to the next step here, it's connect disparate data sources, create a logical view, combine them into business-oriented views, and then consume them in business applications. There may be some people here that are more technical. We can now then look at a few other components beyond the abstraction, the transformation, the cleansing of the data, but all this is being done in the virtual world without copying and moving the data. And that allows you to expose the data the way the business wants to look at it. And then you then execute the queries through this platform, which then gets the data using various acceleration technologies, optimization, caching, in-memory processing, etc., to deliver the data to the application. So you have this balance between IT wanting the things on the right, which is governance, security, monitoring, audit, and business being able to get what they want at the top. So let's go back and look at a couple more customer examples of how this is happening. This is really the concept of data virtualization. It's not to replace your databases or your data warehouse. It's not to replace your processes that you're using, but to then put an envelope of a logical architecture on top of that. And this is a technology that's not new. It's been there for 15, 20 years, but the improvements in the network, the processing speeds, the capabilities, and companies investing in this has made it, according to Gartner again, one of the it's given the highest maturity rating. So if you look at the right side of this graph, there are lots of technologies that are hyped, but when they reach the plateau of productivity, what that means is that the technology is stable, low risk, and delivers high value. So Gartner predicts that by 2022, 60% of all organizations will have some concept of data virtualization, and they will gain as much as 45% in terms of cost alone. On top of that, time to market, etc. advantages. So, how do we, who is using it? Well, every industry is using it today. These are just some examples of Denodo customers, but I'm not going to talk about my company as much as about the technology. And to illustrate that how different people are using it, now I'm going to go to a few more case studies of some larger companies in different industries. And this gives you an idea, again, of how this has the power to transform your digital journey. Visa. Everybody uses Visa, MasterCard, American Express, etc. Visa has basically, these are, by the way, all slides from these companies, not from me. So that also tells you something about how they think. Now, the previous model, as you can see on the left at the bottom, is very traditional. All the data is stored. It's copied into a data warehouse, a data mart, an extract, so on and so forth. In the right, you're able to deliver more of a virtualized approach to this. And this improves the reliability, the security, the self-service. I'm not going to repeat it. Some of these are very technical, complex models with lots of joins and many columns. But this is all being done in the virtual world. Therefore, they don't incur cost as much as in the physical world. And yet the business gets what they want. Visa is using this not only for internal reporting, but also to report to all the banks that issue Visa cards. And they found another use for this. They collect all this data and mask it and sell it to product companies and advertisers and monetize the data by making the data valuable to advertisers as to what do people spend money on, because they have all this information in their credit card swipes. Here's another super complex technical slide. Autodesk, that makes manufacturing and design automation software called CAD tools. They made a fundamental transformation of business model. They used to sell packaged boxes like your Microsoft Office or any tools in the shelf. People used to buy it, install it on their desktop, and then use these design tools. Autodesk completely transformed their business to a 100% subscription model. And that means they got lots of clickstream data, customer usage data, et cetera, and they had to capture all this in that big data lake, that drum that you see. But the ways that the data came in were so many that they wanted to isolate the users on the right side from all this complexity, so they put in the data virtualization layer. And a third and last company, or maybe I have one or more, Intel. Everyone knows Intel. Intel is the chip manufacturer that powered a lot of our PCs, laptops, even today. For a large company like this to make this statement that you see on the right side, which they publicly presented at a conference like this, data virtualization is a game changer for Intel's data. It's a very powerful statement. Why they say that is because it not only delivers the lower cost for Intel, what was even more important was the time. The time to develop a new chip, if it was delayed by 3 months or 6 months, could cost them billions of dollars in market share. The time to deploy their new analytic systems, etc. So Intel, in this case, is not just using it for analytics. If you look at the bullet points on the right, 23 out of the 26 business units within Intel is in some way or shape using the logical business areas that are created through data virtualization. They have trained thousands of users on taking those data services and building applications on top of that. And they're seeing 50 to 80% productivity gains, as you can see in these charts here. Time to market, time to value, time to engage, time to have impactful analysis, and the journey continues. And finally, or maybe a couple more here, Caterpillar. Again, now I'm going back to big names, but these are not all technology companies. That's my point. You don't have to only be a Netflix or a Google or a, they are advanced, in their capabilities. But also regular companies, manufacturing companies, retail companies, banks, telcos, hospitals can use this technology. So now I have a manufacturing example. Caterpillar makes these big machines for mining, oil and gas, for construction, etc. They found that their products may be a little bit more expensive to buy up front, but they were telling their customers over the life cycle of using a Caterpillar truck, you will save more money than using our competitors. Why? Because we have the technology built into these machines that transmit sensor data. That sensor data, which is called IoT, is being captured and combined using data virtualization with multiple other data sources like parts inventory, customer data, dealer data, service level agreements. And that is all captured and displayed in a dashboard in a tool called Tableau to present predictive maintenance recommendations for their customers. So by taking this big data and turning it into predictive maintenance recommendations, their customers are seeing more use of these trucks, more productivity, therefore actually the trucks cost less than using some of the competitors. So change the business model. And Prologis, they build out warehouses, which is kind of a boring business if you think about it. I'm just building these big warehouses all over the world for other customers to use. But the cost of time and speed with which they locate the warehouse, where to get the lease, where to buy the land, how quickly to build the warehouse, and what should be its shape and format, takes a lot of decision making. So they use all of these data sources and build, as you can see, lease, square footage, the customer information, valuation of the land, and they start building into other different business models. Now business people can understand this data: occupancy, leasing, valuation. These are business concepts, but they're built up in this logical layer, and then present it to the analytical tools. And as a result, first step, expose the data to the data scientists. Data scientists now spend 80% of the time doing analytics instead of 80% of the time finding the data. And based on that, they operationalize the model and they drive real-time decisions that reduce the capital costs and the time to release these new warehouses. So, my final points: you've seen many examples. These are normal companies, day-to-day companies. They are here in Turkey. They are here in all over Europe, in all over Asia. And we think the way to take all these ideas of big data, analytics, digital transformation, and make it happen quickly and with low cost is by adopting logical architectures. So definitely data is very critical in your advanced analytics and digital initiatives, but it is very difficult and time-consuming to find and access. As a result, lots of companies are failing in their initiatives because they put a lot of money into data initiatives and they don't see the results. Logical data access can make it easier and quicker to find the data and actually gain the results in a much faster time frame, and it accelerates time to value, decreases risk and cost, and ensures better outcomes. And this is us. You can find us as one of the sponsors here. We're globally present, and we can tell you more. And keep in mind that this is a technology now highly recommended by several analysts like Gartner. So, teşekkür. Thank you.